everyone, and welcome to this Google Hangout from Element 14 with people. We've got guys from MathWorks, and we're talking about Simulink today. So we've got on the Hangout, we've got Anuja Apte from MathWorks, and we've also got Tyler Del Sesto, and he's one of the student ambassadors there. So I'm going to hand over to Anuja just shortly. But one of the things that I wanted to run through with you guys is the Q&A functionality. I can see that a lot of you guys have kind of worked out how to use that. But just for those of you that haven't, I'm just going to give a really quick overview of how that works. So first of all, you need to be in Google Plus and watching the Hangout. You can't do this from YouTube and into YouTube. You need to actually be in Google Plus to ask questions. So when you are in there, at the bottom of the right-hand corner of the viewing window, click on Ask a New Question, type in your question, and then click Submit. It's really simple. I'll then dig those out, post them to the top, select them, and then they'll be answered by somebody on the Hangout. So what we're going to do today is we're going to give an overview of Simulink and also a demo, and then we'll have the Q&A for any questions at the end. So thanks very much to everyone that's watching, because we've had a really good response to this, and I can see that there's a lot of people that are interested. So hopefully you're all on, you're all able to watch. Any problems, drop me a question, and I'll try and see if I can work that out while the guys are speaking. Otherwise, I'm going to hand over to Anuja now to give an overview of the software.
Thanks, Jen. As you know, we are here to talk about programming hardware with MATLAB and Simulink Student Suite. And so I want to show you the product first. So when you get the product, this is what it's going to look like. It's a box with MATLAB, Simulink, and 10 popular add-ons. So it includes control system toolbox, image processing toolbox, and a bunch of other toolboxes that are very popular with our student users. So just when you're using these products, remember that they're used daily by engineers and scientists for various applications. So ranging from financial modeling and analysis to launching space shuttles. So these are powerful tools that you can use for your hardware products, hardware projects. So I know you guys are probably thinking, okay, how do I program my Arduino and Raspberry Pi with these things? So let me show you a picture for that to kind of cover an overview of how MATLAB and Simulink can talk to hardware. So I'm going to share my screen here, so bear with me for a minute. Hopefully you can see the picture that's on screen. So for working with hardware and MATLAB and Simulink, there are two approaches. And each approach is focused on a different user goal. So for example, if you want to read data from sensors on your hardware board, it may be a Raspberry Pi, Arduino, or another hardware board that you're using in your project. Let's say you want to read the data from an I2C or an accelerometer or something like that to analyze it in MATLAB. You can use the top approach in this case, where the hardware board is always connected to the computer. So the key point here is that you don't have to wait for your code to compile. You just talk MATLAB with your hardware board and get the data in MATLAB and do the analysis. Now let's look at the second goal. So if you want to program your hardware for standalone operation, so let's say you want to put your Arduino on a robotics platform with some controls algorithm on it or something like that. In this case, you're going to use the bottom approach, where you're describing your system as a Simulink model and then automatically generating code that will then run on your hardware board. Once the code is deployed on the board, you can run it as a standalone operation, without having to connect it to the computer that's running MATLAB. So instead of hand coding in this case, you're describing your system as a block diagram, and with the push of a button, the code runs on your hardware board. In fact, the demo I'm going to show later today will cover both the approaches. So with that, let me jump right into the hands-on part and show you how to install the support packages, as they're called. I'm going to share my screen again. Here's the MATLAB desktop, as you can see. Now, I've seen a lot of comments on the Hangout asking for prerequisites for this session. And I understand that some of you may be familiar with MATLAB more than your hardware boards, and some of you may be more familiar with hardware boards as compared to MATLAB and Simulink. And hopefully we can cover both the sides today. So this is what MATLAB looks like for those of you who haven't seen this. It's an interactive development environment, and you can write scripts. It's a programming language, so you can write scripts to connect to your Arduino, as I mentioned earlier. You can type commands in the command window that get executed, and then there's a workspace where you can visualize variables and so on. So it's a full IDE that you can get started with. Now back to the support packages for Arduino, Raspberry Pi, and other hardwares. To install those, once you get the student suite, what you do is you go to this add-ons button on top, and then click on Get Hardware Support Packages. When you click on this button, it's going to ask you for how you want to install the support package. Select Install from Internet. Once you do that, you will see a list of free support packages available from MathWorks. And there are a number of hardware boards that are supported here. A lot of these are for commercial use, but many are for student suite users as well. And so, for example, if I select the Arduino support package, you can...
Anuja?
Yep.
It's locked onto your MATLAB, the desktop, and not the window to install the support packages, the screen share.
Oh, okay. Let me fix that.
You can just screen share the...
Yep, the whole thing maybe. Thanks for that.
Yep.
Let me share the entire screen, and then... Sorry about that. Right, so hopefully you can see the support package installer window now. So in the support package installer, there's a list of hardware boards supported, as I mentioned. For example, if I pick Arduino, you can see what versions of Arduinos are supported and what type of support package is it, MATLAB or Simulink. And so you can pick the one you want and install it. There's another one for Raspberry Pi, there's one for Lego NXT, and so on. So this is basically how you get started with the support packages. So I think I'm going to stop sharing for a minute, and then I can show you some resources on getting started with MATLAB. If in case you're familiar with hardware and you can start with the support packages, there are a ton of examples to get started. But if you're new to MATLAB and Simulink, the student suite page on mathworks.com gives a lot of resources for you to get started. So let me share my screen again and show you how to get to the resources. So if you're on mathworks.com, I would go to Academia and then click on For Students. In here, there are a ton of resources available for Student Suite users to get started. So let's look at the tutorials, for example. So there are tutorials geared towards specific applications like signal processing or control systems that you can pick and view these short videos to easily get started with MATLAB and Simulink once you get the Student Suite. Another resource that I would highly recommend is the community. We have over 1 million users of MATLAB, and many of them are active on this community, contributing projects that they've worked on, answering questions. So, for example, MATLAB Answers is the forum where you get your questions on the products answered. If I look at File Exchange, that this is the repository for student-submitted projects and MATLAB files and Simulink models. Now, because our demo today is focused on Morse code, we can look for that file. But basically, as you build your hardware projects, you have thousands of math, engineering, and plotting functions available to you through the product itself as well as through the community. So let's look for Morse code for today's demo. If I search for Morse code on the community, I'm going to see number of submissions that have been made by users that either translate text into Morse code or text into Morse code and turn it into sound and so on. And here is the submission that we're using for today's demo. That's actually put together by Tyler, who's here with us today. So I think I'm going to, at this point, stop sharing the screen and pass it on to Tyler to talk a little bit about how he made the demo and how he uses Simulink for MATLAB and Simulink as a student.
Yeah, thanks, Anuja. Yeah, so I'm a student ambassador at Carnegie Mellon, and that just means I work with students. I run tutorials on how to use the MATLAB and Simulink Student Suite with the students and what kind of projects and research the students are working on. And a lot of the students are really using it for all their coursework. A lot of professors really want stuff done in MATLAB. And as I said, research and projects, most students will use MATLAB and Simulink because it's just easier to manipulate data and do rapid prototyping of things. And on the hardware side of things, MATLAB connects to abundant different numbers of hardware. I noticed one of the comments was, does it connect to a BeagleBone? And it definitely does. There are separate support packages for most hardware devices. And all of the current releases will use these. I saw another comment about that. And then I think you have to have 13B or later to use some of the most recent support packages. But there's definitely legacy support out there on File Exchange, actually. Yeah, so for this demo, I just wanted to use some of the Morse code stuff that I'm really interested in. And Morse code, if you don't know, it was originally made for telegraph and radio operators, and it's basically a sequence of turning on and turning off a signal so that you can transmit letters over a radio wave. And they used this throughout World War I and World War II because it was much more robust than some of the voice-over radio commands that they had at the time. And the voice commands weren't really feasible and not as secure as the Morse code was. And it's still used today. Definitely amateur radio operators use Morse code to communicate. And everybody's call sign on the radio networks has to be in Morse code still. And also satellites who transmit have to have a call sign in Morse code. So for my demo, I wanted to go a little bit farther. And so instead of using a simple optical or an audio thing with sound, I went a little farther and used the LEDs to create blinking Morse code. And optical Morse code in this fashion has been used by like lighthouse operators or something to communicate with ships. But this is actually using it to talk between Arduinos. And this is a totally automated thing I built. And it's got a little bit of artificial intelligence to figure out what's going on, which is kind of cool. So programmatically, there's a few connections to the Arduino. There's potentiometers to adjust thresholds. There's buttons to control the program. And then there's the LED to transmit things, and then there's the photoresistor to kind of pick up the signals. And so these are all connected directly to Arduino, and one of the Arduinos, as Anuja said, is connected directly to MATLAB. And so through MATLAB, we can actually communicate with the Arduino, and using the command line, ask it what readings its sensors have at that instant in time. It's all very real time. It's great. One of the things in the program that it does is there's an analog to digital converter with an adjustable threshold, and that was kind of fun to put together because you use the potentiometer and adjust that on the fly, which is great. Really good for any online calibration people do. I know in my research I'm doing online calibrations, and having some of the Arduino inputs is really great to be able to quickly adjust things. And then the other thing is there's an automated decoding algorithm inside the program. And that's actually running on one of the Arduinos and connected to MATLAB. So MATLAB is able to use, and the programmer is able to use the full suite of MATLAB products to decode this message and do signal processing really on what message has been received through the Arduino. So it's a really powerful connection between the hardware and the software in this case. And so that's all really fun. I guess I'll pass it back to you, Anuja.
Yeah, so one question I had for you, Tyler, is maybe it would help the audience to learn a little bit about how you've used MATLAB and Simulink beyond this demo, like in your coursework, and what kind of courses did it help with, and what kind of projects you built there.
Absolutely, yeah. I know, as I was saying earlier, students use it all the time for coursework, either if it's recommended or if it's required, but many students just go there because it's easy to work with things. And MATLAB really specializes in any kind of optimization or statistics or control system development, especially on the Simulink side of things. Simulink is the block diagram development environment, and MATLAB is the programming language, like a Java or a C++ kind of thing. And so for my experience, I've used MATLAB in all of my artificial intelligence classes, all my robotics courses, always use MATLAB for either simulation or large data set analysis. It's really quick, it's built in, and all of your graphical interfaces with MATLAB are right there. So it's easy to plot things, easy to adjust the plots, and easy really to see what the data is doing in real time if you're connected to hardware, or if you're just processing large data sets or simulations offline, it's still a really useful environment. And it also has a built-in object-oriented part, which I've used for some projects, and even robotics projects to simulate different parts of systems and using objects, but still using the MATLAB powerful commands.
That's great. Yeah, so I think with that, I think looking at the time, I think we should get started with the demo and probably show you the two Arduinos talking to each other. So let me share my screen again, and I'm going to show you a picture just to give you kind of an overview of the demo itself. So what we have here is we have two Arduino Uno boards. One is a transmitter, which is programmed with Simulink, so it's running standalone, transmitting a message through this green LED, and it's programmed with the Morse code message encoding. And then we have the receiver Arduino Uno, which has a photoresistor that's listening to this LED. And this is actually connected to MATLAB and is using the MATLAB support package. So as soon as you get data through this photoresistor, it's read in MATLAB and it's converted to its equivalent text message, if you will, and that will be displayed on the MATLAB command window. So that's what the demo is all about. Let me show you my setup here. So this here is the transmitter right here. As you can see, this LED is blinking continuously. It's transmitting the message here. And then this is the photoresistor and the receiver part. Now all these wires and the rest of the circuitry you see is for calibration of the photoresistor that Tyler mentioned earlier, where we want to make sure that the photoresistor is calibrated correctly to receive these messages. So that's our setup. Let's go to MATLAB and see the receiver in action. I'm going to reset the transmitter so it starts transmitting the message from the beginning. And I'm going to go to here. Start this. And then run the receive message command to see those in action. So as you can see, the first letter it received is H, and the Morse code is ... and then so on. So let's see what these Arduinos are saying to each other. So as you can see, as soon as the photoresistor receives a letter, it immediately gets displayed on the MATLAB command window. So it's a very interactive type of operation because the photoresistor Arduino is actually tethered to the computer and is talking to MATLAB interactively. So now that we've received our message, let's see, the complete message is hello. Of course, they're saying hello to each other. And as a part of it, part of the analysis, you can see the voltage versus time read by the photoresistor. So you can do all kinds of analysis. This is just a simple example of how these are talking to each other. So now that you've seen them in action, I actually want to show you what it looks like when it's actually running. I'm limited by screen space here, so this is what it looks like in action, where the LED is actually blinking and the photoresistor is reading the characters. So now that you've seen this in action, I'm going to jump into some of the details and show you how we got here. Let me stop the receiver. And let's start with the transmitter. Since it's simple, I'm going to spend some time on that. So I'll open a Simulink model, which is called a transmitter beacon, is the name of the model that I created. It's a really simple model where you see the input. There's a block that has the input text, and then it's connected to the digital output block here, which basically programs the LED next to the Arduino. And so let's look into this input text block and what it has. So here, essentially what you input is ones and zeros. You can input any numbers, series of numbers here, and that's what this block is going to output at a sample time of 0.25 seconds. So that's what this block does. Now, to make it a little more automated, I have given it a MATLAB function, text to Morse, and with the string, whatever string I want to put here. So let's say I want to change the string here to MATLAB. So this having a script just makes it easy for me to change, just change the text, and the numbers will automatically change here. Now I also have a legend here that says, okay, what does a dot represent, what does a dash represent, and so on. So let's test this actually just with a simple letter. Let's test A, right? And let's just run the simulation instead of programming the Arduino directly. So I'm going to run it for, let's say, 5 seconds, because it's not going to take us that long. And then I open up this scope block that shows me what numbers this block is essentially block's output. So let's see. So dot is a 1 for 0.25 seconds, and dash is 3 ones for 0.75. So this looks like a dot dash. And let me take up my cheat sheet for Morse code here. Dot dash is instead indeed A. So now if I change this to M and run it before 10 time units, I run this. Oops. So if you look at M for Morse code, it's dash dash, and that's what you see here. The point I'm trying to communicate here is that you can interactively tune your parameters, tune your system before you program your hardware. So there are ways to visualize the data and to change parameters and tune your system before you program your hardware. So now let's put a new message in here. Let's say I change this as MATLAB, right? And I'm going to run it maybe for 30 time units, just to test it that it's working. I need to run it for a little bit longer, maybe. Now this is basically showing me the text for MATLAB here. So these are the 5 letters that we transmitted here. And now I'm ready to program my Arduino Uno with this algorithm. All I need to do is to click this button to deploy it to hardware. So I'm going to click this button and then monitor the different messages that are at the bottom of the model. And you can see that it's building the model and then preparing to run it on Arduino Uno. You can see the progress bar here, and soon it will be deployed to the board and ready. The transmitter will be ready to go. Now, as you can see, the model is successfully deployed on the Arduino. Now we can test it again. With our receive message. So we clear the command window here and reset the transmitter so it starts sending the new message, and then look at the window here. So this is a simple example, but there are many other examples of, let's say, programming robotics platform that are available on Element 14 as different projects. There's also a contest going on right now on Element 14, Teachers Pet Students Competition, and you'll be surprised to see the kind of complex algorithms and projects people are able to put together with MATLAB and Simulink Student Suite and their favorite hardware. So I encourage you to go to Element 14 and look at the different projects that are being done using MATLAB and Simulink. Now, with that, we have seen the Simulink part of the hardware connection. So we covered the transmitter part, which is this guy here. Now let's look at the receiver part and what we have to do to work with the receiver. Now, for the receiver, as if you remember, is always connected to MATLAB in this case. And so if I open the Arduino setup.m file, you can see that the different steps you have to take are really, it's a short script to connect to your hardware. And most of it is actually data. So here, in this line, you create an Arduino object called myArduino. You specify the COM port that you're using and the kind of Arduino you're using. And then the rest of it is basically saying, which pin number is it connected to, and then going ahead and configuring the different analog and digital pins so you can talk to the pins. And then if I open the receive message script, of course that one is a little more complex, and it not only decodes, so it basically reads the message from the Arduino and then decodes it depending on the Morse code vector. So at this point, I think I'm going to stop sharing the screen and ask the demo author actually to see if he has any inputs. Inputs on what was the most difficult part of the demo, how did you put this together, because I literally got Tyler's files and a couple other files, made some improvements, and this is how I'm showing you the demo. So off to you, Tyler.
Thanks, Anuja. Yeah, so I was really excited how the demo works, and Anuja's done a great job implementing the whole Simulink side of things. That's really cool. On my side, I focused mostly on the MATLAB connectivity part, and what was really cool doing this through MATLAB was that I was able to really rapidly prototype my an algorithm to determine what signal was being sent. So you could test one letter at a time just by having your Arduino connected directly to MATLAB. and I actually was running 2 Arduinos off one MATLAB and kind of having them talk to each other, which was kind of cool, just when I was testing the algorithm. Although that was also one of my biggest challenges because there was a lot of letters to go through, a lot of timing and done. But I think it would have been a lot harder in the basic Arduino IDE or anything that I couldn't use some of the more signal processing type functions that MATLAB has. And I definitely used the functions in that because it was great to segment out the code and say, okay, this part's done. I want to make that its own function. And that's all very easy to do in MATLAB. MATLAB is very function-based. So I could easily create modular code that is really reusable for other tests as well.
Right.
One of the easy things. Oh, sorry. Yes.
No, that's fine. Go on.
Yeah. So one of the easy things was actually doing the calibrations. So you can see that, I don't know if you remember that plot, had the red signal, which was the photoresistor, which is picking up light, and then the blue line was actually the threshold, and that threshold is adjustable online using the potentiometer. So as you turn the potentiometer, it basically changes the voltage input to the Arduino, which is directly sent to MATLAB. And I just have a little loop running that says, okay, read in this voltage, and then output that to the threshold. And then that threshold is as used in the analog to digital converter. So you can, and online this is, adjust the threshold which does the analog to digital converter so that MATLAB is processing the signal correctly. And this would have been a bit of a challenge somewhere else maybe, but in MATLAB it was very easy for me because it's just 2 connections and then you can adjust it and fiddle with it as you want to get it right. And it's good for this one especially because the lighting conditions always change. And I know some of the comments were about, I think, motion detector activations with things. And definitely MATLAB is really great because you can actively interface with the sensors here. So it's really good for any kind of calibration systems you want.
So I'm just trying to demonstrate what Tyler is saying. The red and blue lines are the 2 voltage lines, and if I put a paper between the red LED and the photoresistor, it kind of senses that the voltage changes go below the threshold. And this is how I had calibrated the photoresistor before starting up the demo. This is what you were referring to, right, Tyler?
Yeah, exactly. And it's just that easy. It's you start the program and then you can do all the hand calibrations. And then when you're done, it just saves it all automatically, and it's still all in MATLAB and accessible from the command line if you'd like to change it or update it later. So yeah, it was pretty straightforward. It was good.
Right. So one other thing I wanted to add to your commentary, Tyler, you mentioned reuse, and one of the things that are easy to do with the Simulink interface or even MATLAB, you know, once you have your algorithm in this tool, you can, let's say, you want to use the same model that we used for the transmitter, and now you wish to change your transmitter board from Arduino to, let's say, Raspberry Pi. It's really easy to do here. All you need to change is this block that is talking to an Arduino to an equivalent pin on a Raspberry Pi, and then the way you set up your hardware would change here on the hardware side to whatever other hardware you might have connected there, including Raspberry Pi. So, you know, being able to reuse your work, your core algorithm on different hardware boards is really a useful feature of this tool as well. And so if you are looking for examples to get started on the support packages, you can go to MATLAB and open up the documentation, and at the bottom of your documentation you're going to see all of your support packages that you have installed. And let's say I go to the Raspberry Pi support package, for example, I can look at different examples here and different demos that help me get started. So whether you want to get started with the hardware or using specific sensors, you can start using these examples to start building your hardware projects. Just one fun project that one of my colleagues, Madhu Govindrajan, who is pretty active on Element 14, he had built for holidays. He put together a short script for Raspberry Pi through the MATLAB approach, where Raspberry Pi is tethered to MATLAB, and he used a webcam to detect faces of folks who were showing up at his office. So something like face detection is really a few lines of code in MATLAB, and you can get it up and running on the Raspberry Pi just as quickly as you can work with Arduino. So yeah, I think that's what when you were talking about the demo, Tyler, I heard reuse and kind of piqued my interest. I wanted to mention this other use of the tool for Raspberry Pi and other boards.
Yeah, absolutely. And also the MATLAB community is really, they have so many resources out there, so you can always pull code down and have other people's code help you out if you need it. I think it's all available on File Exchange or some of the other sites. Like
Yeah.
Maker has some good projects too, yeah.
Yeah, maybe we can close up the presentation part by showing one instance of it. And then I also got another file from MATLAB File Exchange, the MATLAB Central File Exchange, and I was able to hold on one second. Let me just test it before I run the demo. So yeah, so I was able to run this another file which converts Morse code into sound using MATLAB. So I use that to convert the Morse code into MATLAB. So I'm going to show you that part real quick. Go to MATLAB. And so here what I'm doing is I'm reading the complete message into a WAV file and then playing it back. So we can close up with this part. Hopefully you got to hear the Morse code sound. I had a lot of fun, but my colleagues were frustrated by these strange sounds coming from my office. So
I bet.
On that note,
mine was much quieter because it was just flashing the LED.
Right.
So I've noticed there are several questions on the side, and some of them I have some answers to, and some of them are a little more complicated, and I don't think I'll be able to answer, but I think I'll just take a minute to talk to those a bit. There was one about using voice recognition systems to activate LEDs or activate other kinds of systems with voice commands, and that's definitely possible through MATLAB. It'd be pretty easy to hook up a audio input device to either an Arduino or a Raspberry Pi or a BeagleBone and have that display in MATLAB the audio file, and then from that you can use any signal processing you want in MATLAB, which has a whole toolbox for it. So you can use that signal processing to do any kind of voice command calibrations or even identification. So that's definitely a very feasible project, and that'd be really cool. If you make that project, definitely post it on File Exchange. People would be really interested. Yeah. There was another question about how to control stepper motors, and that is very easy. It's connected. The Arduino hardware support package has some things to. There's a specific thing to control motors. So it controls stepper motors and servo motors and all that kind of stuff. And you can specify different signal types. And definitely on the Simulink side or the MATLAB side, they're pretty one-for-one on their capabilities. Just Simulink, you are deploying to hardware. MATLAB, you having that connectivity. And I think that steps into another person's question, was how to convert MATLAB code into a program. And I assume you mean how to deploy it to hardware. Currently, you'll have to use the Simulink interface to deploy to hardware because there's a lot of background programming actually happening there. And the MATLAB is a direct connectivity only kind of setup. But the MATLAB support package, or the MATLAB suite, comes with MATLAB and Simulink for students. So you'll definitely have all the tools you need to convert your code and your Simulink models directly into hardware that runs independent of MATLAB or tethered.
Right, and there's also a block called MATLAB function block in Simulink.
Yeah.
And so a subset of the MATLAB language is supported for code generation through that block. So you could move your algorithm, a MATLAB algorithm, in the Simulink environment and still generate code for standalone operation.
Yeah, definitely. Thanks for bringing that up. That's a very important fact. They're very highly compatible. And then just looking through some other questions.
One question was, do we need to always make a wired connection to the laptop, or is it possible for a wireless connection? It is possible to do like a Bluetooth or a Wi-Fi connection with these boards. You just need the appropriate accessory, and the you may need to do extra work on MATLAB or Simulink side to work with the accessory. But yes, it is possible to work with Bluetooth and Wi-Fi.
Definitely. There's one question about installing MATLAB actually on your Raspberry Pi. And I've definitely seen some online resources about how to do this, but usually you have to augment the Raspberry Pi's processing and memory capabilities to be able to fit this in. But I think I've seen some demos where kind of a truncated version of MATLAB or just the basics were implemented. And I definitely like to see how that progresses in the future. I think they'll be improving that. There's one about calculating steps when people are walking and kind of doing a statistical study on people's walking. And actually, one of the projects I was helping with last summer when I was an intern at MathWorks was kind of a step detection using an IMU in a phone that was directly outputting to MATLAB over the internet. So that was an internet-connected device, and using that, you were able to do all these algorithms in MATLAB in real time to actually develop what kind of gates they were using, what activities they were. So that was an activity tracker that one of my colleagues was working on. So that was pretty cool to work with. And so definitely try that out. It's very possible.
So one more question I see is this specific for Arduino and Raspberry Pi? And as Tyler mentioned earlier, we are picking Arduino and Raspberry Pi as the popular hardware boards, but the capability is definitely not limited to these hardware boards. There's different types of support packages, including MATLAB support package for BeagleBone Black. There's also support packages for webcams. So various hardware instruments and boards are supported, and you can take a look at the list on MathWorks website.
Mm-hmm. Definitely. And under the Arduino suite, I know Arduino Uno, Mega, and Due are definitely supported. And then I think there's some other additional ones on MATLAB's site that under the Arduino suite individually. But as Anuja said, there's definitely pretty much comprehensive support for all low-cost hardware that's out there.
Right. I see one more question. Can we see the MATLAB and Simulink block diagrams for this project to get an idea? As I showed you, the MATLAB side of the demo files are already available, along with sort of a cheat sheet of how to put together the circuit on MATLAB Central File Exchange repository. We can post a link to that particular submission right on this Hangout page right after this.
Yeah, that's definitely a exchange.
One other question, how can I find these packages? So I showed one way of doing this through the product, but if you're just browsing, I want to make sure I show you another way of getting there, which is basically from mathworks.com, going into, go to mathworks.com/hardware to look at different hardware support that's available through MATLAB and Simulink. And if you look at vendors list, there's a long vendors list that is supported. Some of these are supported with the student suite. Some of these are more for commercial applications. But I just wanted to show you that there's a variety of hardware supported with MATLAB and Simulink, and this is where you can get the complete list.
Yep, absolutely. Yeah. There was another question about how do you use GUIs to interface with microcontrollers, and I don't know if you've used MATLAB before, but MATLAB actually has a whole GUI development environment kind of thing. So you can drag and drop blocks and create your windows and applications in MATLAB, and they run off MATLAB. And then because the hardware is also integrated with MATLAB, it's easy to make callbacks from buttons and have displays right into your GUI. So it's actually very straightforward. A lot of the overhead for the graphics of the GUI are handled by the guide command, GUIDE. That's kind of the graphical environment development kit that MATLAB has. That definitely comes with the student suite. I've used that. It's pretty cool. It's very easy to just hook up a few things and have them all display in your GUI. Definitely a great way to use the microcontrollers.
So
another thing was MATLAB support for I2C and SPI sensors and that kind of devices. And definitely the Arduino support package has all that, and I'm sure the other hardware support packages have a version of those kind of development. Both on the Simulink and MATLAB side, you'll definitely be able to use MATLAB with the I2C and SPI connections.
Right.
That's really interesting.
Yeah, I would for that I would refer you to the MAT. We frequently post tutorials on here, and as you can see, there's one on using MATLAB and Raspberry Pi with an I2C sensor and other sensors as well. So keep an eye on the MATLAB YouTube channel as well.
Definitely. Yeah, that's a really good resource. I've watched a lot of things on that to get to know how to do things. Yep. There were a few questions about embedded C programming. I'm not sure if this is a toolbox you can get with the base student suite, but you may be able to use it as an add-on. And there's an embedded coder toolbox, which will allow you to basically make your programs and make your code in MATLAB or Simulink, and then develop them in a C environment automatically. So it automatically creates a C code. And this is really important for my research. We're using a DSpace controller in our system, our robotic system. So we make everything in MATLAB and Simulink, and then we build it in C code and develop it embeddedly on the DSpace controller. That's very easy to do, very straightforward.
Right.
Using the toolbox.
And yeah, just to clarify, embedded coder is not yet available on the student suite, but a lot of times on your school campuses have bought these tools for teaching classes, and that's where you can get access to these tools as well.
Yeah, definitely. So I think we'll maybe skim the questions one more time and then try to see. Thanks for all the great questions. It's been really cool to get some input from really all around the world.
Yeah, this is pretty awesome. Yeah, one question. Can you please upload the demo video? I think, Jen, correct me if I'm wrong, but I think this automatically gets recorded and posted on YouTube right after the event, right?
Yes, it does, yeah. Can you guys hear me?
Yes, we can.
Oh.
You're right.
Great. Sorry, I've been having some technical issues this end. So.
Okay.
That's great. And I was also going to say there are loads of questions, more than we're ever going to be able to get round to. I've tried to make a note of as mmany as I can, and I think what we'll do is maybe post some answers to those questions on our Google Plus page. I think that's probably the best thing to do, just because I think we're kind of way over time as it is. So, so I guess with that, I'd like to say thank you very much to Anuja and Tyler for taking part in the Hangout. I'd like to say thank you to everybody that's watched. It's been great. We've had loads of participation in this one. We've had loads of questions, more than we've been able to answer. So thanks very much for doing that. And thanks for bearing with me as well as I drop in and out. I'm having some technical issues this end, so apologies for that. Hopefully it didn't interrupt everybody's viewing. And unless there's anything else from Anuja or Tyler, I will wrap up.
No, I think we're good to go. Thank you so much for listening.
Yeah, thanks, Jen. Thanks, everybody.
Great stuff. Thank you, everyone, and thanks and goodbye.
Bye.